Assalamualaikum students. I hope you will be good. Today I'm doing differentiation. This topic has been introduced in IGCSE Mathematics, IGCSE Math, and a new topic which has been introduced in IGCSE Mathematics is derivative. There are some changes made in this syllabus. So one of those changes is derivatives, sometimes called differentiation, or now okay, there are some simple rules which we will be doing and will be learning them, and these rules we will be using in questions. When we will be doing derivative questions, we will be using these rules. For example, if y is equal to x power n is given to us and they say find derivative or differentiate this thing, so we will be doing dy dx is n x power n minus 1. Now similarly, if they have given us y is equal to x power 5, this is an example, so example now, then what we will do, dy dx is 5x power, according to the rule, 5x power 5 minus 1, so it becomes dy dx is equal to 5x power 4. Okay, now example number 1, this is, I'm doing example number 2 now. See, this is the main rule, this is the main rule now, and I'm using this rule and I'm solving different examples. Example number 2, so y is equal to x power, let's say x power minus 9, so dy dx becomes minus 9 x power minus 9 minus 1, so it becomes minus 9 x power minus 10. That is the result. Okay, these two examples I did. Now I'm doing one more example. Example 3. Example 3 is y is equal to x power 2, so dy dx becomes 2 comes here and x 2 minus 1, so which is becoming what? It becomes 2x power 1. Now these three examples I did. The main theory is here, that's the main theory. Okay, now one more example, one more rule. This is rule number 1. Okay, now if there is a situation like this, if they give you y is equal to a x power n and they ask you differentiate, what you will do, dy dx is equal to c. A is constant, so constant into power, see here we were doing n, we bringing n to the coefficient and then decreasing the power which is n by 1. So the same thing we will do here, bring n to the coefficient and then decrease n by 1. So result comes a n x power n minus 1. Now what is the example for this? Example for this is y is equal to 5x power 3. Now see here, okay, this is constant like this, see a was constant here and 5 is constant here, n was power there and 3 is power here, so I will do dy dx 5 into 3 x power 3 minus 1, so result becomes 15x power 2. Now similarly they can give us another example. I'm taking Now this was example number 1. Especially for this case, for this rule, this is, let's say, rule 2. So example here for example 1 for rule number 2. Example 2 for rule number 2 is y is equal to, it's y is equal to let's say minus 5x power minus 4. Very simple. dy dx, it becomes minus 5 according to the rule. See, this a is the constant, so a is remaining there, minus 4 comes here, so into minus 4, the power comes to the coefficient and the power is decreased by 1, so minus 4 and minus 1. The result becomes 20x power minus 5. That is derivative for this function. Last example, example 3. Y is minus 10x power minus 2. So see, dy dx is minus 10 into minus 2 x power minus 2 minus 1. So result becomes 20 or 1, yes, fine, 20x minus 3. So that's the result. Okay, now one more thing, I will call that rule number 3. Basically this is basically one rule, but one rule has different like we have different situations. So I'm just making rule 1, rule 2, rule 3 for your understanding. Rule 3, now y is equal to, see here, boys and girls, they are students. So our rule 3 is y is equal to 5, yeah, let's say constant here, not 5. So constant is writing px, yes, px is a function. So if I'm finding derivatives, so derivative is becoming dy dx. Now this becomes p. If I'm having y is equal to ax and I'm finding derivative is dy dx, it's a. If I'm having y is equal to cx and I'm finding derivative, so derivative becomes dy dx, it becomes c. Now why it's becoming p, it's becoming a, it's becoming c? What is the reason? Look, this one, look at this one. Y is equal to px, so dy dx is equal to p, power is here 1 into 1 x 1 minus 1. So result becomes p into x power 0. Now if something is having power 0, like see, anything to the power 0 is what? It's always 1. So it becomes p. Similarly, look at this one. Y is equal to cx. So dy dx is equal to c. Now power is 1 here, so bring 1 here, so x1 minus 1. So c into 1 is c and x power 0. So c is the result. Similarly, the same thing we can do in this case. Okay. So in simple, we don't need to do all these things in every question. In simple, if we have y is equal to 5x, what will be derivative? Derivative will be just the number 5. Okay. So these three rules, basically these three are different, these three are cases which we can see in questions. Okay, case 1, case 2, case 3. Now there is one more case which we can see in our questions, which is this one. See, y is equal to constant. If there is a constant, y is equal to suppose 5, and there's a find derivative. So derivative will be what? dy dx is 0. If y is equal to minus 5, dy dx is 0. Now if somebody is saying, sir, give me I don't understand this thing, make it very clear to me, so that I can see that 0 is coming there. Okay, how the 0 is coming? I want to see the 0, how the 0 is coming. Look, I'm showing it to you. Can we write y is equal to 5 is y is equal to 5x power 0? Can we do this thing? I'm writing y is equal to 5 is y is equal to 5 into x power 0. What is x power 0? It's 1. When x power 0 is 1, then of course 5 into x power 0 is again 5. So there's no difference. See, x power 0 is equal to 1. So this 5 into 1 is again 5. Okay, now I'm raising here. Now, I was doing y is equal to 5, and I was showing to you that how it's becoming dy dx 0. Now see how it comes 0. See here, I can write y is equal to 5x power 0. Can I write? Yes, of course I can write. Now differentiate. So dy dx is equal to, according to the rule says if we have 5x power n, then the rule says dy dx becomes 5 into n into x power n minus 1. So similarly, we will be doing 5 into 0 x power 0 minus 1. What is this thing, students? This thing is basically 5 into 0 is what? 5 into 0 is 0. So 0 into x minus 1. Everything multiplied by 0 is again what? 0. So this is basically, if somebody is interested in getting how and seeing how this derivative of the constant becoming 0. So this is for him or for her. Okay. Now let me do a question, an example, where I will be combining all these three cases in one example. Okay. Example is y is equal to x power 5 plus, I will not do it here, or it is here. You can copy these, this working. Okay. So y is equal to x power 5 and x power 4 plus 5x power 3 plus 2x plus 9. Now we did, see here, we did different cases. We did this case. See here, I'm doing it. I'm erasing also this part. If you see the video from the beginning, I just did this thing. See, I did y is equal to x power n. What was the derivative? Derivative was dy dx is equal to n x power n minus 1. Yes, I did it. Example was x power 9. So dy dx is 9x power 8. Yes, I did this thing. Then I did this thing also. y is equal to p x power n. So dy dx is equal to p n x power n minus 1. Yes, I did this thing. Example was y is equal to 5x power 4. So dy dx is equal to 20x power 3. Yes. Then y is equal to 5x. I said dy dx will be what? Will be just the constant. Then there was y is equal to 9, a constant. So dy derivative of the constant is always 0. This is basically, this derivative is a very important topic. Differentiation is very important topic. Differentiation and integration, these are two topics. These are very important topics, and but we can't do in very much detail in IGCSE, like in course which is in syllabus of IGCSE. Okay, because it's not in that much detail in IGCSE. And yeah, when we go to A-levels, there we will be doing this derivative thing in detail, inshallah. Now, so let's do differentiation. So dy dx is 5x4 plus 4x3 plus 15x2 plus 2 and plus 0. Okay, now the result is dy dx is equal to 5x4 plus 4x3 plus 15x2 and plus 2. That's done. That is the derivative. Okay, now there are a few more things. You know, this dy dx, you have done this thing in previous classes, but in another form. Basically, this dy dx is your gradient, which is gradient. How? Look, I'm asking a question. How this is gradient? Look here. If this is a curve, let's say it's a curve, and there is a point here. At this point, there is a line tangent to this curve. Let's say this line is tangent to this curve. Tangent is a line which is just touching the curve at one single point. So let's say this is our tangent line. Yes. Now this point, I'm writing the point here. This point is 2 and 5. Okay, now basically I want to tell you how the dy dx is m. I want to show that thing to you. Look, I'm just taking this is just an example. This is not the exact curve. I'm just taking a simple function, like it's not exactly for this excuse me, this is not exact equation for this curve. I'm just saying y is equal to x square plus 5x plus 9. Just example. Okay, this is just example. Now differentiate this thing. Dy dx is 2x plus 5. Now what I'm doing, I'm getting the gradient of this tangent line. This is a tangent line. This tangent line is touching this curve at this point 2, 5, and I'm getting, now I want to get the gradient of this tangent line at this point. To get the gradient, and you know gradient is what? Gradient is, students are writing here, gradient is basically m. So to get gradient, I will put this 2, the value of x is what? Value of x is 2. So put the value of x in this function. So dy dx is 2 into 2 plus 5. The result becomes 9. So gradient for this tangent line, is having gradient, because you know the equation of tangent line is y is equal to mx plus c. So m is basically the gradient. So the gradient of this tangent is coming 9. Okay, so this is how we find the gradient of a line. Now I'm giving another example, then I'll be doing question from some books or some other supporting material. With some more sheets. Look, another example I'm taking. Y is equal to 5x3 plus 5x2 plus 9x plus 5. They say find derivative dy dx. So derivative becomes 10x plus 9. Now if I'm finding the gradient of gradient 8, find gradient 8 x is equal to 2. What we will do, dy dx is equal to, see, x value is 2, so 10 into 2 plus 9, which is 29. That is the value for gradient. Now one more thing, this is parabola, and we have done this thing. This is quadratic. Quadratic function has curves like this. Quadratic functions have curves. When we get the graphs are named parabola, and sometimes it's opening up, sometimes it's opening down. Now if this graph is opening up, do you see here this point? This point is called vertex. Okay, this is vertex, and vertex is x and y. This is called vertex, but this is also called minimum point. Okay, now one more name we can use for this point, that is called turning point or turning point. Now see here, I'm showing it to you. I'm coming from here to here. See, I'm moving this way, coming down, coming down, coming down, coming down, and suddenly I move up from here. Okay, I move up, so I'm turning my direction here, just up to this point, or at this point, exactly at this point. So this point is also called turning point. Okay, now turning point, it's sometimes called minimum point, sometimes it's called stationary point. This point is sometimes also called stationary point. Now to find stationary point or to find turning point, we will find dy dx and then make it equal to 0. So whenever you are finding turning point or you are finding stationary point, just get the derivative and make it equal to 0. Like, for example, look here, I have a function y is equal to 5x square plus 10x plus 9. Now I'm finding the turning point. So to find turning point, find derivative dy dx. It's 10x plus 10. So to find turning point, I told you just few seconds earlier, I told you for turning point are stationary point, make dy dx is equal to 0. So if I make dy dx 0, then dy dx is 0, then 10x plus 10 is equal to 0, and x becomes what? Minus 1. So if x is minus 1, put this value of x in this function. So y becomes 5 into minus 1 square plus 10 into minus 1 and plus 9. So result becomes 5 minus 10 and plus 9. So 4 is the result. So it means a turning point becomes x is what? X is minus 1. Y is what? Y is 4. That's a turning point. This is also called stationary point, and sometimes this point is maximum, sometimes this point is minimum. When the parabola is opening up this way, then the turning point or a stationary point is maximum, minimum. When the parabola is opening down, in that case it's minimum. Inshallah, in next video I will be explaining to you, I'll be doing questions where we will be explaining this stationary point and this turning point. We'll be finding them. uh, and inshallah, okay, we will see. Inshallah, we will meet in the next video. Inshallah, Allah Hafiz.